So here's the basic situation. You type in a sentence, the AI gives you a picture. How does that actually work? What's happening between the words that you use in your prompt and those pixels? So you don't need to know the full math. You just need to understand a rough picture of how it would work. And the analogy that I would use is that understanding how the tool works changes how to use the tool. For example, a photographer who knows about how a lens works and f-stops and shutter speeds, he or she just naturally takes better pictures because they understand the underlying framework of how everything works. To understand where we are today, it helps to see how we got here. There have been three major eras of AI image generation, each one built upon the last. So let's start with GANs, Generative Adversarial Networks. You can think of this as the forger versus the detective. It's a cool idea. We'll talk about this and how this made inroads on initial image generation things where you might have heard of deep fakes and those kind of things that arose in this era. Then we move to the era of diffusion. So you can think of this as basically noise sculpting. This is what DALL-E is, if you've heard of DALL-E. DALL-E's from OpenAI. Midjourney is another important company. Stable Diffusion. These tools use what we would call diffusion, which is basically shaping images out of noisy starting points. From there, we moved into the more current era where we've started to see the application of autoregressive ideas, and it's sort of a hybrid between autoregressive and diffusion. And so that's what we're seeing with GPT-4o, the latest and greatest things from ChatGPT, and then Nano Banana Pro, which is from Gemini. So each thing's built on the last. So today's frontier models build upon these things and implement multiple approaches. I wanted to start with GANs, Generative Adversarial Networks. This is where the whole story begins, and it's kind of a cool idea, so I wanted to include that this topic in our discussion. So the idea is that you have two neural networks that are actually competing against one another. There's the generator that creates fake images trying to fool the other network, and so the other network is being trained to discriminate and tell, which one is the fake and which one is not the fake. And so if you train these together and put them up against each other, they tend to generate very realistic looking images because of this relationship between detecting and making adjustments that the forger makes and rerunning the detection stage again. So it's a cool idea. But it's not where we are today, but it was an important starting point for generating images with learning networks. Next up, we're going to this important approach that is called diffusion. So think of this as a noise sculptor, and this graphic that I generated using ironically, I'm using generative AI images to talk about generative AI images, but this graphic shows the process. So there's the forward stage where you do training. Okay, so what's happening here is we start with this image, and it's hard to see on the first frame, but there's just noise speckles added to each pixel. And so you add a little bit of noise, it gets a little bit fuzzier, and you train on how do I get rid of that noise? So it's predicting the noise and trying to clean that up in the training stage. And along the way, there's probably text descriptions that are added in here to help associate text descriptions with the kind of noise that is being removed. Okay, so you add progressively more noise until it just becomes this random set of pixels, all right? And you're training at each stage to try to eliminate that noise. So then the idea is to run that in reverse. When you're actually generating images, you have some text that's built in, correlated with the training. You start with a noisy background field, and then you just start sort of, based on the text, it's starting to put some shape, it's starting to remove some noise, and an image starts to emerge at the end until you get the final generated image. So your text prompt steers this denoising process, And so if you can be more specific, more detailed, you'll end up with better results. So at this point, I wanted to take a little step back and talk about some of the players that show up in generative AI in terms of generating images. There are lots of different AI labs working on this, but here are the things that probably emerge if you take a look into generating images with AI. First of all, there's DALL-E, and I think that's interestingly named. It's a mashup of WALL-E, remember the movie WALL-E, and also Salvador Dali, the famous artist. So that's the namesake. It's one of the first diffusion models, and you might have heard a lot of DALL-E 2 and DALL-E 3 when they were first started. It's tightly integrated with ChatGPT, and if you're on the free version, you're likely doing some version of a diffusion type model that's coming from ChatGPT. There's also Midjourney. Midjourney's its own AI company, and it's known for generating images, and that's their business. And so they have an architecture that helps guide the diffusion process and different schemes and different ways of doing prompts, and so some structure added around generative AI for images. And so a lot of creative type people are, have subscriptions to Midjourney and use it for that purpose. Another thing that's an important player is Stable Diffusion, and that's because it's open source. So we've talked about open source before. You can download this, you can modify how you tune it and all those kind of things. And importantly, it can be run on machines that, it might take a high-grade system that has GPUs, but you could run it on your own hardware. And then along the way, there's Gemini that has come up with something that rocked the world when Nano Banana first came out. It's a little confusing, the naming point, because Nano Banana arose because a lot of these AI labs don't identify their models, and they put them out on some competitive model evaluation boards. And Nano Banana just slowly rose the ranks as people were trying out generative AI. And it was such a kind of memorable name that became the name that people use for the model. Along the way, though, sometimes Gemini calls it Gemini 3 Pro, and it's a full reasoning model, and it's integrated in with regular chat, and so it gets a little confusing. The bottom line is, if you want the really good image generation coming out of Gemini with your Gemini subscription, is you want to use the Pro. We'll go through that in class, but Nano Banana Pro, and you get there with Gemini 3 Pro. If you see it just saying Nano Banana, you're probably getting diffusion only and not diffusion with some autoregression, which we're going to talk about in this presentation. I should also mention that there's a lot of other players, and so I put a few icons down here to illustrate this. Adobe has some products with AI integration built in, and so it becomes a mashup of different things where you have things like Photoshop with some AI capabilities, and you can make some really good images using a lot of these different tools that you can find if you're really interested in generating images. So if you think about the process of diffusion, you can see some built-in limitations that would come from the process of how they're generated. So first of all, the model learned what text looks like, not how to spell. Okay, and so it bases its training on making images, not so much putting text into images. And so you really get some wonky kind of results that come out from pure diffusion if you have any kind of text that you want in your images. There's also some issues with spatial reasoning, because it's correlated and it doesn't have logic built into the training process. If you want to put, a red cube on top of a blue square, that kind of thing is harder because it doesn't really understand the physics of things. It's more about, I've seen red cubes and I've seen blue spheres. I'm going to generate those, but the spatial reasoning is not built into the training. So that becomes a problem. And then there's consistency. Every generation starts from fresh random noise. And so if you want to edit an image, it doesn't really work, right? Because you're going to get sort of maybe the same type of process, but you can't have fine-grained control by the way it's starting from just a blank slate of random pixels and evolving into the finished image. So we're going to look at these quirks and how the AI labs are working on different types of approaches to address the limits of diffusion. When you first think about diffusion and the idea of starting from a blank slate of random noise, it makes it seem like it'd be impossible to edit. But you can make some adjustments to your mental model of how this works to extend this to where you have a better idea of how image editing and text might fit together. Okay, so ironically, I asked Gemini to make an infographic, and I wanted to show the challenges of integrating text in particular from a diffusion model. Now, the first iteration of this, the text came out perfectly throughout the whole image. And so I wanted to have an iteration where I was telling it to intentionally mess up the text, all right? And so it got that. It just put it, in my opinion, in the wrong order, all right? But the point is, it's trying to do this process when I made this image to teach you about generative AI image generation. Also, ironically, some other spelling errors crept into the process. So you can see it's still imperfect, but it's gotten a lot better. All right, but let's talk about how this works. The challenge is when text comes into the play, it's not trained on that. We've talked about that in the previous slide. How does it work if you're going to implement text and things like editing? All right, so in this example, we're showing, here's a picture of a dog with a leash. Can we edit this image to take the leash off? All right, and so the idea is that you can use some masking. This is very familiar if you've used Photoshop, but you select some pixels, like here's the pixels that show where the leash would be. All right, so now you can say, oh, here's the surrounding context. Here's the pixels that I need to adjust. Let's turn those back into noise and have the image emerge just inside that mask where we want to make the edits. And from there, because it's taking the context of the rest of the image, it can do surprisingly well at some of those edits. All right, text is a different thing. Text, there needs to be some planning about where the text goes, and you have an advanced training kind of situation where you're trying to have these layers where you have text that you want to put into different places on the image. And so the basic idea here, in my takeaway, is that yes, you can add text and you can make some edits across the image with text, but you need to give it an idea of where the text would be. And so you can do that with some of your prompting styles and make it to where it can make a little more, more precise edits. But as we can see from this particular example, it's not perfect. All right, but it gives you an idea of what to do. Okay, so that's another feature that's evolved with this diffusion approach towards generative AI creation of images. So the next era, I would call it era 3, is where you use an autoregressive approach towards generating images. So autoregressive, you can think of that as, oh, we're going to do one step and then we're going to move over and do another step. And so it's taking the next step, but it, regressive in the sense that it goes back and it looks at previous pixels to encapsulate the information that shows up in the previous work. So the way I would look at this is it's very much how ChatGPT generates text. And in fact, if you look at this representation over here in the image, you can think of an image as just having little sections of pixels that act like tokens. Okay, and so because we've seen, or we have lots of images that we can train on, we can get the same kind of predictive structure that comes out of images as we do from regular text. It's kind of a crazy abstraction, but it still works the way that language works. And so that's pretty cool. So one way of thinking of this process is you have some text that you give for a prompt, and it's starting to take those tokens and make predictions with an image model, and it's trying to predict what should the next pixel be based on what I have for the text and the image that's emerging, and push these things all together to give you a more coherent structure about your image. Okay, so that's probably not a great explanation, but the idea is there's diffusion, but there's also token-based things that happen that connect all this together to let us have better image generation if we combine this autoregressive approach, where it's very much like treating images like text along with diffusion. All right, so that's where we are these days with some of the more advanced image generation models. Okay, the next thing I wanted to work on is developing a mental model for how a hybrid system would work on constructing images that are generated from text prompts. Okay, so maybe think of it this way, that you're trying to build up an image and you have the idea of tokens and token predictions. That comes from the autoregressive nature of image generation. And you're building out a basic blueprint or construction plan, and so you can rough some things out that are based on this predictive token kind of model. All right. It's got a great analogy to actually painting as well. So with painting, you typically lay out an underpainting that has the basic shapes, and then you go back through and you fill in the details. Okay, so I don't know if this is a perfect description of how these systems actually work, but this is good enough for a mental model of how you can use this type of approach to come up with a better plan for making images. So you fill out this blueprint, and then the diffusion model starts to fill in the details, and so you start to get better about what you want. From there, you can make some edits. All right, so basically you're trying to give it some text prompts. Based on those text prompts, you're going to try to give it location of where you want to make edits. You want to give it as much description as you can, and it's going to make the decisions based on probably an autoregressive kind of thinking, where it's taking your prompt, taking those into tokens, predicting what needs to be happening with the image layer to make the diffusion step work better the next time around. So hopefully that gives you some idea of how these things kind of fit together. Let me zoom back out here and talk about how diffusion has trouble with pattern matchings and shapes. It has trouble with editing. You can do some inpainting tricks, and you can augment those inpainting tricks with a hybrid model to get better results. It has some issues with statistical matches. This has some reasons about the request to help you build up different aspects of the image. In fact, I've experimented some with hybrid imaging, and it can get some spatial reasoning things that you can't get out of a pure diffusion model. So these are some advantages of the hybrid approach. You don't have to know exactly how it works, but I think having some inclination, like we've been talking about, helps get you further along in terms of creating better images. Okay, so for Gemini, all right, you have a subscription to Gemini. There is Nano Banana Pro. Nano Banana Pro implements likely, people aren't publishing exactly what it's doing, but it's likely implementing a combination of diffusion and autoregression, where it has some planning and some logic that goes in, and then use the diffusion to create the images. If you just use plain Nano Banana, so watch that whenever you're using Gemini. Gemini is going to probably want to auto-select a model. If it's using just plain Nano Banana, you're likely to get some text errors, and you wouldn't be able to edit that image very well. So this is a place where model selection becomes important. You want to go to Gemini and drop down and select Gemini Pro, and then you would get the Nano Banana Pro model to make better images. Another interesting aspect of how things have evolved over recent years is the trend is that everything becomes tokens. All right. So before we had large language models that had text, and then there's some separate effort on images. And if you think about it, audio is very much the same way. So you can take text and images and sequences of images or video. All right. So all these things are just a sequence of tokens. Okay. So we have tokens. We can unify this into a single model where we have everything put together: audio, video, tokens. We can even go three-dimensional. And so that's the way the world is going in terms of generative AI. All these things are integrated together. Okay, this is going a little longer than I wanted, but I wanted to close with just a quick primer for how understanding how all this works helps you make better prompts to make better images. So here's the strategy. Know the blueprint. Use the autoregressive structure. So define the structure first, and you can give, for example, a futuristic city with a skyline. Give as much information as you can to help rough out this initial stage. And then you guide the finishing with diffusion details, so you can see where the prompt would be, adding more details to your image. And then once you go to edit, you need to be specific about where to locate the edits that you need to make within your image. And basically the idea next is to just iterate to get to the best result. Now, sometimes it's a problem if you try to overthink this. All right. Sometimes you just want to have a rough idea, get started. You have some broad ideas that you want to put into an image. You can just go ahead and get started and go into this editing mode. But a lot of times the original scaffolding looks wrong, and it's very hard to get it to move past the original layout. My advice would be, if it's looking totally off, that means you need to just jump into a new chat, because it's going to be hard to get it to move very far off of the original structure. So those are some good tips to hopefully help you make better images. Okay, and of course the best way to learn to get better at making images is to practice making images. All right, the AI prompt that I used to help make this presentation gave you some experiments to try. I tried these, they're kind of cool. You can work on different styles of making text. You can see in one image, you can make different types of rendering. That's an interesting thing to try. Try some things, but you can go with these experiments or do experiments on your own. I encourage you to try that. The next thing I wanted to talk about was the AI wanted us to investigate how to break the models. Okay, so it was really interesting to try this. Try to break it with a red cube on top of a blue sphere to the left of a green cylinder in front of a yellow pyramid. Well, you know what? Because it's got some reasoning capability with LLMs, and it's doing this autoregressive thing, when I tried this in Gemini, it thought really carefully and built up essentially another prompt before it put this into Nano Banana Pro. And you know what? It came up with the perfect representation of this. So it didn't break. The other thing is, we know that LLMs in general are bad at counting. All right, there's some workarounds for that where it maybe calls a tool, and figures out how to count. Well, they've also fixed the counting problem, at least mitigated it, because with this prompt, I put this into Nano Banana Pro and it got this perfectly right as well. So of course it's not perfect, there's still edge cases where you can break it fairly easily, but these are making progress by leaps and bounds, and image generation is a big deal within the AI space. So hopefully you've come away with some ideas on how image generation works. You're understanding that the future is many modalities, everything's a token, and these things are kind of coming together within the frontier lab models that we see. So the best way is to just get out there and try to make these things work for you, make some images, make some infographics, do some things to make you understand how image generation works with AI.